Okay, so again, just a few ideas before we go ahead and get started. I've got all these bullets up on the front board. Waivers are going to be due Friday by 10 a.m. to Marcia Edwards, Mr. Young's secretary. You just walk in there, get one from her, go ahead and fill it out, and then Mr. Young will most likely approve or deny depending on whatever the circumstances are. So we're not talking about just for this class, any weighted class or upper level class you have. If maybe you unfortunately failed the first 6 weeks and you need a waiver because you're in athletics or something like that, okay, that is going to be a deadline of Friday by 10 a.m. Now, not tomorrow, Thursday, we are having a tornado drill. Okay, during second period. But if we were to have a tornado drill in third period, where do we go? We go downstairs. Okay, we're going to go right along the 1200 hallway and stop where? By that art office. Okay, so the corner art office right there across from the vending machines, right there in the main hallway, because we want to try to fit everybody in the main hallway. It's going to be probably a little uncomfortable. You're going to have about 3 or 4 people deep facing the wall. We're going to want to try and get a path in the middle so that administrators, teachers can go up and down, give you instructions if necessary. Okay, so that is happening on Thursday, so we'll be looking forward to that. Also on Thursday, we have our first quiz of the 6 weeks. What's it going to cover? Inverses, okay, so I don't think it's going to be too difficult. It's going to be very much along the lines of the homework that I'll be passing back, and hopefully I'll get those other homeworks that are turned in today back to you guys tomorrow, so that's coming up as well. Again, we're still just under a few weeks out from this, but the first exam is going to be on Monday, October 8th, so tomorrow we're going to come in. We're going to have our next focus activity. We're going to go ahead and grade the homework that I'm going to pass out at the end. And then I also want to go ahead and do an in-class exit ticket over the difference quotient, get a little more practice on that with a larger function, and then we'll see if we can go ahead and get started with trig. If not, we will definitely finally start our trig unit on Thursday and then kind of see how far we're going to get. Okay, any questions about what's going to be happening? Okay, well, let's get to it. We were talking about the difference quotient. And as I was saying a little while ago, the difference quotient is going to help you find a derivative, which will allow you to find the slope at any value of x, the tangent line at that particular location. So if you're still a little, like I said, hesitant about taking the limit as h approaches 0 or any of that, for right now, we'll just put that to the side. I just need to go ahead and make you feel comfortable using the formula itself, which is f of x plus h minus f of x, all divided by h. So the numerator has 2 parts. My first step is to always take every x in my function and replace it with x plus h. Okay, so if we're taking a look here, I want to find the derivative of 3x squared minus 5x plus 4. So both of those x's, 3 times x plus h squared minus 5 times x plus h plus 4, that represents the first part of the numerator. Then the second part, I always want to subtract the function itself. So if it's a binomial or larger, I encourage you to put it in parentheses so you don't forget about distributing that negative. All right. Now, h, remember, that just represented the horizontal distance between the 2 values that created your secant line. Okay, it's going to be part of our answer. In some way or form, we're going to have an h there. But your derivative, when you get to calculus, will not. All right. So we did get this at least set up yesterday, right? Oh, no, I know we did x squared, but did we at least set this one up? We did not? Okay. Well, I've already got it set up. Okay. Because 8th period yesterday, that's as far as we got. So is everybody okay with how I applied the formula to 3x squared minus 5x plus 4? And it doesn't matter what your function is, it's always the same steps each and every time. First plug in x plus h, then subtract the function, it's all over h. So really a lot of today hopefully should be pretty easy. Again, this is just going back to your Algebra 1 skills, expanding, distribution, your like terms, all that good stuff. So let's see here. What would I get if I expanded x plus h? Or squared, I should say. There we go. Okay. X squared plus 2xh plus h squared. You can go ahead and write x plus h times x plus h in FOIL, or we talked about a rhyme, square the left, square the right, you double the middle. It's out of sight because we talked about right not being a really good rhyme for that. Of course you remember that, right? Yes, of course, of course. So now I do want to do one more thing because that first term, it's not just expanding the square, it's distributing the 3. So now I'm going to multiply each of these by 3. So that would be 3x squared plus 6xh plus 3h squared. Okay. So that takes care of this first part right here. Now somebody distribute the -5 for me. Minus 5x, minus 5h, and we have the plus 4. And if I'm subtracting the function, all it's going to do is change what? The signs. So this would be minus 3x squared plus 5x, and then minus 4. Of course, this is all divided by h, that horizontal distance between my two arbitrary values of x on the number line. Okay. Well, when you do this, you're going to start to notice as we go through the formula, once you expand, distribute after that first step, you're going to come across several opposites, several pairs. Like what's going to drop out here? Okay, so we have 3x squared minus 3x squared. Okay, negative 5x plus 5x. 4 minus 4. So it looks like that's all the pairs that are going to cancel. So I have 6xh plus 3h squared minus 5h all divided by h. So once you've canceled out all the pairs that you can, now you look to see how you can simplify the h's. And I think yesterday I took the numerators and I just broke them apart because if you're going to add or subtract fractions, you have to have what? A common denominator. Well, the rule is reversible. All of these numerators have the same denominator in h. So I could write this as 3 individual fractions, and then we could simplify that way. We could factor h out of the numerator, and then just simplify that way. Okay, Stephanie, what do you like? How would you like to simplify? Separately? Okay, let's do that. So I'm going to write each of these individually. Get rid of that. So I'm going to say 6xh over h plus 3h squared over h minus 5h over h. Okay. The rule about adding or subtracting fractions with a common denominator is reversible. So maybe this is going to be a little easier for folks to see. Okay, those cancel. Okay, one pair of h's will cancel right here, and then those cancel. So my final answer, okay, from the formula, I'm looking at 6x plus 3h minus 5. That is my answer. Now, that's not quite the derivative. I was showing you yesterday how we take the limit as h approaches 0, just because I wanted you to kind of see the big picture. But that is what you're going to be doing when you get to calculus. Okay? All I'm going to require is that you simplify the formula after you plug in. So that's what I'm looking for. Okay. Any questions? Anybody not seeing where I got something? Okay. Well, let's try another one. Okay, next example. F of x equals 3x minus 1. Okay, so I have a linear function this time. All right, let me go ahead and get this out of here. Okay. So what is the difference quotient again? F of what? So f of x plus h minus f of x all over h. Okay. So the first step in applying this formula is to do what? There you go. I'm going to replace every x with x plus h. So 3x minus 1, 3 times x plus h, minus 1. Okay, now what? Okay, now we always subtract the function I'm trying to find the derivative of. So I'm going to subtract it. Because it's a binomial, I'm going to put it in parentheses. 3x minus 1. And then we put it all over h. There you go. So it really depends on the function that you're going to be provided. You could have, quite a bit of work, or it could be just something pretty small and straight like this one. All right. So there's no squares, so we just go ahead and distribute. What would I get if I simplified the numerator? 3x plus 3h. Okay, minus the 1, minus 3x plus 1. There we go. All over h. Okay. So I substituted in. Okay. Expanded what I could. Do I have any pairs that'll cancel? So 3x's, the 1's. So it looks like I only have 3h over h, and those h's will cancel. So what's my answer? It's just 3. Okay. And sometimes that'll happen. That's it. This is the difference quotient for us. It's not the equation of the line, but it's going to give you the slope at any point. Because think about it, if you go back to the original function, the slope of a linear function is always what? Constant. Constant, okay? So if I go back to 3x minus 1, any value of x that I choose to investigate, the slope will always be 3. And remember, that's what we're provided here. We didn't get something like that on the previous one because we were dealing with a quadratic. And the slope is constantly changing as you curve your way around that function. Okay, think about how many tangent lines you would have. Okay. All right. Let's try another one. So I've got another standard form quadratic. X squared minus x plus 1. Okay. So what's my difference quotient? I think it starts with an F. Well, I mean, you could. The formula itself, we really never changed it, but you could go ahead and say g of x plus h minus g of x over h. But typically, even based on the name, people just go ahead and tend to use f just because it's most common. But yeah, you could do that. Okay. So what do I do first? Okay. Susie? Every x in my function, I'm going to replace it with x plus h. So x squared, x plus h squared, minus x plus 1. Okay. Now I'm going to subtract the original function. So x squared minus x plus 1. And this is all going to be divided by h. Okay. And now we just go ahead and expand. We start looking to see what cancels and go from there. So x plus h squared. What should I put? X plus h squared. X squared. Okay. Minus x. Minus h. We got a plus 1. Minus x squared plus x minus 1. Okay. All over h. Is anybody having a hard time seeing how we're doing this? Okay. Now what? Okay, so what drops out? X squared. X's. 1's. Okay. So it looks like I have 2xh plus h squared minus h all over h. 2xh plus h squared minus h all over h. So for this one, why don't we go ahead and factor out the h just so you can see a different way of doing it. What would the trinomial up top look like if I did remove the h? 2x plus h minus 1, all divided by that h. And now because it's joined through multiplication, I can still cancel those. This is my answer. This is what I'm looking for. 2x plus h minus 1. Okay. Questions? Okay. What's different about the next one? Okay, it's in the denominator, so we have our first rational function. Okay, so this one, let's try. So 1 over x plus 2. So I'm going to write the difference quotient first. F of x plus h minus f of x, all divided by h. So what's the first fraction in the numerator? Remember, first step is to replace every x with what? X plus h. So I'm going to start with 1 over x plus h plus 2. That's a plus. Okay. Now I'm going to subtract the function itself. 1 over x plus 2. And this is all divided by h. Now for this one, in the numerator, I've got two fractions, and I've got to combine those if I hope to simplify. So I need a what? A common denominator. What is the common denominator? X plus 2, that's part of it. Now think about it. Ultimately, we're going to be taking the limit as h approaches 0, so h will be disappearing.
Seventh period music theory students need to go to the orchestra room for class today. Again, seventh period music theory students need to go to the orchestra room for class today. Thank you.
Hey, how you doing? Thank you. Enzo. You know, I'm not quite sure after hearing that announcement if I like Mr. Anderson's tone. I get it. He was talking about music students' tone. Yeah. Okay. You think if the music students showed up at the wrong room, they'd be told to beat it? If they don't show up, are they going to be in trouble? Okay. Moving on. You'll laugh later. Okay. Hey. All right. So it is not x plus 2. What we were saying about h does represent a numerical value because that is a distance between the x's we're looking at on your axis. So think about it. I would have to include the h in the common denominator. Hello.
Okay, so Carrie gave me this to give to you. This is just where we ordered them from.
Okay.
This is the date that she got the quote. So she probably ordered them after this. So I think we got them in March.
Mm-hmm.
So all you need to know is tell the people, don't call them. Don't call this number.
Okay.
You're going to call TI.
Okay, so call Texas Instruments
Yes,
themselves.
and just say, I have a calculator that we ordered back last year. We got them in March, and it's not working.
Okay.
And they'll talk you through what to do. And then if it still doesn't work, then they just need to, they'll tell you what to do to send it in.
Okay.
But you don't call them. Just if they say, where'd you order it? Say, we ordered it from D&H Distributing. We ordered in February, but we got them in March.
Okay.
We've had it since March, so it's not even a year old.
Okay.
But just call TI.
All right. Thank you so much. All right. So good. I've been waiting on that information. Okay, so we have a trinomial and a binomial. The fact that we have the h is significant because it represents a numerical value. I mean, x plus h would still represent just another value, right? So the common denominator here is going to be a product of the two. Okay, so we have to multiply the two together in order to get the common denominator. So we're going to come up with an equivalent fraction. Over here, we're missing the trinomial. So x plus h plus 2. Okay. While over here, I'm simply missing the binomial. X plus 2, x plus 2. Okay. Now, remember, I'm not wanting to change what the value of the function is. I'm just changing the way he looks so that I can manipulate him. Okay. What's anything divided by itself? 1. When you multiply anything by 1, It remains the same. We're just multiplying it by a version of 1. Okay? So I'm going to go ahead and do this. Okay? If I go ahead and multiply these two fractions together, they're going to have the same denominator. So I'm just going to go ahead and pull everything together and have x plus 2, x plus h plus 2. Now, x plus 2 times 1 would remain x plus 2. But there's one thing I don't want to forget when I multiply in the second fraction. What am I referring to? Distributing the negative. We don't want to forget about that negative as I go through. So this is going to be minus x minus h minus 2. Now there's something else that I'm forgetting. What do I still need to put here? This is still all over h. All we're taking care of right now is the numerator. So this is all over h. Okay. So we still have a fraction where the numerator itself is a fraction. But what do you notice about the numerator of the numerator? Again, does anything cancel? Yeah, so the 2's are gone, the x's are gone. So it looks like I have negative h over the common denominator all divided by h. How do I simplify this? Okay, so teach. There you go. So a couple of different ways. If you're dividing by a fraction, you can multiply by its what? Multiply by its reciprocal. So I could easily say that this h in the denominator is just h over 1, because that's equivalent, right? So I can just multiply by that reciprocal and have this. Okay. So I'm going to have this negative h over the common denominator, x plus 2, x plus h plus 2, times 1 over h. I multiplied by the reciprocal of just h over 1. There's another way that you can kind of look at this if you don't want to think of it in terms of the reciprocal. If you have a fraction, let's say a divided by b, you could separate the numerator from the fraction itself as long as it's still joined by multiplication. So I could say this would be a times 1 over b. So really, you could think of it, I just took this whole fraction, just pulled him out in front, times 1 over h. Okay? So either way, it makes it better for you to think of it. Okay? There's one last thing I can do here. The h's, they can cancel on the diagonal. But when these h's cancel, that leaves me a negative 1. And let's go ahead and finish by multiplying those polynomials together. So negative 1 over. Somebody distribute the x for me. X squared plus xh plus 2x. So that takes care of the x. Now distribute the 2 plus 2x plus 2h plus 4. And out of all 6 of those terms, what are the only like terms that I have? Just the 2x's. Okay, so instead of writing it all again, I'm just going to replace the 2x plus 2x with 4x. So let's see if it'll allow me to pull this over. Cool. And that would be what I'm looking for. Not quite the derivative because we still have those terms containing h, but all we're interested in is just simplifying the formula. Okay, questions? Anybody having a hard time? This is exactly what your homework is going to be. Okay. All right. Well, do you feel like you're ready for one on your own? Yay. Okay. Well, let's try this next one. Okay. 2x squared minus 3x. Now, I mentioned earlier, I'm thinking about tomorrow having ourselves a little exit ticket where you'll go ahead and turn in a problem I give you before you take off. But I was thinking about giving you a higher degree because all these on here, the highest degree we have is 2, right? So x plus h squared, we're familiar with that expansion. But I'm curious how many people would know of or maybe even remember this. Is there anybody in here who could expand that for me like that? Okay, so he says x cubed plus 3xh squared. Okay. I think you went out of order on that. But I mean, really, that's okay. 3x squared h, 3x h squared. That's exactly right. Okay. What did he use? What kind of theorem? Okay, so Pascal's triangle. I was kind of referring to the binomial theorem. Does that sound familiar to anybody? Okay, so it's not something that you spent a lot of time on last year? Does anybody not know what I'm referring to when I say Pascal's triangle? Okay. Can anybody tell me it starts with 1, 1, 1. What's the rest of it? 1, 2, 1. In fact, 1, 3, 3, 1 was what we used here because we have a power of 3. Pascal's triangle, the appropriate row, will give you the coefficients of the triangle that you're looking for. Okay? I'll take that, sir. Thank you. Okay. Now, for someone who's not familiar with this, how am I generating this triangle? Okay, ma'am? There you go. I'm adding the values above it previously. So I'm going to start with a 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And 1. So what would the next row be? 1, 5, 10, 10, 5, 1. Okay. So I'm kind of thinking about tomorrow. So giving you a higher degree, maybe like a cube or even something to the 4th power, which even if you're not familiar with this, I mean, it would still be okay because you could just say x plus h, x plus h, x plus h, right? You're kind of worrying me here. We could still multiply those together, right? Okay, so if you know the shortcut, fantastic. If not, okay. All right. So I was just kind of wanting to see about that. But try this one. The 2x squared minus 3x, and it'll allow me to pass back some papers I have. Has everybody who needed the key gotten it yet? Okay, Zach still needs it. Is that right here? Okay, so you're going to read the top one. Does anybody else still need the key? Okay, Savion, Zach, would you give that to Savion when you're done? Okay. All right. Bethany. Kyle. Shane. Erica. Kimberly. Stephanie. Susie. All right. So let's see. Jack. Dylan. Oh, for walls. Miriam. Marunda. Satish. Aiden. Okay, I got Bethany. Oh, Bethany's over here. Ethan. And Bethany. All right. Okay, I've never had the opportunity to do this before. Let me see if I can just go ahead and get the roll before time is up. Okay, so let's see. Jacob was not here. Jack. Elvis. And Christian. All right. Okay. So how many people think they have an answer? Okay. How many people have an answer, but they're just not 100% confident? Okay, some more hands going up. Would anybody like to come on up and show me this one? Okay, so Aiden, you want to do it? Okay. 2x squared minus 3x. Yeah, would you like her to kind of talk as she does it or just write it out? Just write it out? Okay. Would you like the headset? Are you sure? Okay. Do you want to say hello to everybody? No? Okay. Okay, so she's substituting in x plus h, subtracting the function, perfect. And it's all divided by h, good. Okay, so she's going to expand and distribute at the same time. Okay, good. Anybody have any questions so far? No? Okay, so canceling out opposites. So 4xh, 2h squared, minus 3h, all over h. Okay. Final answer, 4x plus 2h minus 3. What do you guys think? How many people got that right? Okay. Interesting, because there's way more hands going up now than when I was asking who had an answer. Okay. All right. Good. Good, good, good. Okay, well, you'll notice I've only got one problem left on the notes, and it's very, very similar to the previous rational function that we did. We can go ahead, work that problem if you want to, no issues with that, or I can go ahead and pass out your homework, and you can take the rest of the time to go ahead and get started on it. Okay, homework. Is there anybody who wants to work this problem? Don't let peer pressure affect you. Okay. Nobody wants to work this. Okay, then we will go ahead, shut down.